Okay, the masked professor is on the air again. Oh, wait, I'm not wearing my mask. I actually started making this video a few minutes ago and I made a really big flub, so I'm just starting over. I'm going to talk to you about lean basics. Lean is lean production or lean manufacturing, which has become a really large deal in industry in the last, let's call it the last 50 years. I created this presentation for my consulting work with Texas Lean, Tejas Lean. What a mistake on my part. All right, ordinarily we would have an exercise at this point, but because this is the time of COVID, I'm in this room by myself. All right, so the traditional view of profit is that our cost is going to keep rising and we're going to tack on profit on the top of that. So that's kind of the traditional view. Whereas the lean view of profit is that we are going to have either a steady amount of profit while we're reducing our cost, or we have increasing profit while we're reducing our cost. All right, so what is lean? Lean is doing more with less. Less time, less space, less human effort, less machinery, less material, while we give the customers what they value. Why do we do lean? Well, the first thing is time is an irreplaceable resource. The seconds that have already gone by while you're watching this video can never be recovered. So I'm praying I'm giving you value with this. Lead time, in other words, the amount of time from when a customer orders something until they get it, is a key to their satisfaction. We do that with waste elimination. There is an unbelievable amount of waste in processes in business and industry. But by knowing what the wastes are and looking for them and eliminating them, we can make more profit. Part of what we do to do that is continuous improvement. We want to constantly keep looking and looking and looking for where is waste and how we can eliminate it. All right, so our key principles of lean. The first is value. Value is what the customers are willing to pay for. The second is the value stream. That is the steps that we take to put together the product or the service that the customers value. Our third principle is flow. We prefer to do things one piece at a time without stopping and batching. Pull means that we are producing on demand to the customer. In other words, we're not producing things that no one wants, hoping we can sell them. We are trying to be in sync with how many the customers will want. And perfection, relentless, continuous improvement. Always looking to improve. All right, so let's talk more about value. Again, value is what the customers are willing to pay for. So any activity, service, etc. that adds value, we are in favor of, right? It's going to change the form, fit, or function of the product or service. On the other hand, non-value added is any activity or service that does not add the value the customers want. Anytime we can, we want to eliminate, simplify, or reduce these non-value added activities. Now, sometimes we have non-value added but necessary. For example, I used to work in the aerospace industry. The FAA, of course, insisted that we have a certain amount of paperwork showing that certain kinds of work had been done, that inspections had been done, etc. All this had to be accumulated together and maintained for as long as that aircraft was in service. So, non-value added, but necessary. All right, so value added work. Customer service is value added. Order entry is value added. Assembly, painting, cleaning, all of these are value added. But never, never, never rework. In other words, having to go back and redo a job because it was done incorrectly. On the other hand, non-value added activities, incomplete information, entering information in two places, waiting, inspection, transportation, inventory, searching, rework. Inspection is one that people often argue with me about. No, we have to inspect. However, you can't inspect quality in. You have to build in the system the things that create the quality. All right, so waste, or muda in Japanese, since of course lean production comes from the Toyota production system that was built over a number of years, Taiichi Ono leading Toyota and getting a whole team around him that helped to make this. There are actually three kinds of waste, muda, mura, and muri. But for right now, we're just going to talk about muda, which is the most obvious. All right, so the first of them is defects. We don't want to hand a defective product to a customer, whether that customer is our ultimate customer or the guy at the next workstation. Overproduction, making too much, costs us money. It used to be the business paradigm was, oh, inventory is good. Inventory is money in the bank. But, like the forward pass in football, for the one good thing that can happen, that is the customer comes in and you have the product he wants and you can hand it to him, get their money, a lot of bad things can happen. It can get damaged. It can become obsolete or obsolescent. It has to be counted. It has to be stored. It has to be guarded. No, pardon me, having to talk a lot here. Waiting. When things are waiting, whether they're products, parts, or people, we're wasting money. We want continuous flow. Non-value processing. We don't want to do more than the customer wants or have to do rework. I know one place where I worked, the inspectors were famous for seeing a part that was installed and had already been installed correctly, inspected, everything signed off, and they would say, take that part off and send it to the paint shop. It has to be painted. But our customer wasn't paying for painting. Transportation. We want to move on the shortest path. Very often you see in factories AGVs, or automatically guided vehicles, that are taking the parts on a tour of the factory. Bloody hell. Injury is a waste. That is going to cost us the money, time, and effort to, first of all, replace our worker permanently or temporarily. That worker is going to have to be trained. The worker who's injured is going to get workman's comp. They're going to have to go see doctors and other medical professionals. And in the worst case, they're going to sue. Motion. We always want to produce with the least movement. Now, I've been studying comedy a long time as kind of a side job. And Art Carney in The Honeymooners, I really love. Because, for example, he would sit down to play the piano, right? And he would stretch and crack his knuckles, and then he would put his hands down like he was going to play. And then he would stretch and crack his knuckles again until finally Jackie Gleason would say, "Get on with it, Norton!" Energy. We want to use the appropriate amount of energy, whether that's electrical, hydraulic, or pneumatic energy, whatever form our energy is in. But it also refers to disconnects. Disconnects of information that make people waste their time is a huge one. All right, remember, waste always comes disguised as honest work that has to be done. And when we start on our lean journey, we are going to have to persuade some people that a job they have been doing for years is not valuable to the customer and has to be eliminated. All right. The next of our key principles is the value stream. Again, that is the steps that create and deliver that value. So a value stream could be considered from the time we get raw material to the finished product or the installation if it's a service, or any portion within that. We could consider the value stream of just one shop or even just one workstation. When we do the value stream, we do the value-added steps and the non-value-added steps. When we do a value stream mapping event, we need to make sure that we understand what is the flow of material and information, what are our value-adding steps, and where are our opportunities for improvement. All right, so in Lean, we like to illustrate the idea of flow with a picture of a river or a stream. Again, we want one-piece flow if we can get it. Now, sometimes that's hard to achieve because the parts we're making are so small, or the product is so small, it just doesn't work as well. But one-piece flow is always our ideal. By contrast, mass production moves products in batches. Batches wait while they're in the way, and they hide defects. With one-piece flow, it can reduce errors, and it reduces our lead time. All right. In manufacturing, we have the idea of push versus pull. Pull, excuse me, not pool. Push versus pull. Push means we just throw a bunch of material out on the floor and say, all right, boys, let us know when you're done. On the contrast, pull is the idea of letting the pace of demand dictate how fast we're going to make things. All right, so using triggers, we keep our inventory low. It paces production to the customer demand. Maybe I should do, all right, so here is a theoretical production line where these guys are making snowmen. All right, I needed something very simple to put together. All right, so when a customer buys a finished snowman, that becomes a signal to this pink worker to grab the partially finished product, the work in process, to finish it and move it over here. That means that now this empty Kanban is a signal to our blue worker that he needs to take the partially finished product here, do his part of the job, and put it over here. And so on all the way down the line. So part of the principle of pull is tact time. Tact is the German word for musical beat. Now, how a German word got into the idea of the Toyota production system, man, you got me there. All right. So, when our demand is known, we synchronize our process. TAC time is a very simple calculation. It is the time we have available for production divided by the demand. All right, so my example is we have a company and they have to produce 20 blivets in one day. And I'm sure y'all know what a blivet is. Wait, you don't? A blivet is 10 pounds of horse manure in a 5-pound bag. All right, so the time that they have available to make these blivets is 400 minutes per day. Okay, we know an 8-hour shift is 480 minutes. And 80 minutes of this time we assume are used in breaks, lunch, setup, cleanup. Okay, so we have 30 minutes in breaks, 50 minutes in setup and cleanup. Okay, apparently I should have been paying more attention. So the time to make a blivet is 40 minutes. that means that our TAC time is 400 minutes divided by 20 units, or blivets. That means our TAC time is 20 minutes per unit. So, our solution is we have 2 workers that each do 20 minutes worth of work on the blivet. Or, in contrast, each one could do 40 minutes of work. The numbers are going to work out the same either way. All right, and the last of our key principles is perfection. Again, relentless, continuous improvement. We're never done with improvement. Toyota, the world champions, say that they still have 20 to 30% waste in their processes, and they're working to eliminate that all the time. Well, if we start in a brownfield is a facility that's been running for a long time without having any kind of lean or industrial engineering look at it. We are going to get big percentage improvements early in our process. I have done lean events in brownfields where we got 50% efficiency improvement or 75% efficiency improvement on the first pass. After a while, though, we're going to get smaller and smaller and smaller percentage improvements, but those early ones are going to fuel our experience and help us to get the more refined ones done. So when we have lean manufacturing or lean production, we have some things that we have to make that work. One of them is a shared vision by all the employees. Everybody from the CEO to the guy that sweeps up have to be on the same page about what our vision is for the company. Everyone has to work together. Management have to give support, and employees have to be involved. Very often what we see is they send engineers down to the floor to do improvements, and it almost never works out because the people who have to do the job don't understand what they're trying to accomplish. Again, our value is always defined by the customer. We're going to eliminate waste in our processes. We're going to build that continuous improvement culture. And one thing that we have to have for this is quantifiable goals, right? Sometimes at a company, you'll have a bigwig come out and he'll say, "We want to improve quality." And that's all they say. Okay, well, what does that mean, though? If you say, "We want 25% fewer defects," that is a quantifiable goal. Just saying we want to improve quality does nothing. All right, so we have to build that lean culture in our company, in our organization. Part of it is people have to be willing to change. This is hard. We are hardwired down in our amygdala, the reptilian portion of our brain, that change is bad. So we have to start out with some very gentle things at the beginning so people can see that change is good and change is helping them. One of the things I do when I go to a new organization or a new shop is I explain to them, look, If your job isn't easier after I leave and more efficient, then I haven't done my job right. We have to build trust between workers, customers, suppliers. Very often in business, it's kind of like, okay, you bought our product, now get out. Or, if you don't want to supply us, we've got plenty of people that do. We want to build relationships with all of these people. If you treat the customers badly, they're not going to want to come back. If you treat your suppliers badly, there's all kinds of things they can do. The quality of the goods you need may not be where you want it. They may keep trying to raise the price on you. So we want to empower and motivate our employees. And we want to support action. Now these last two, sometimes it's hard. It's very hard for management to say, all right, team leader and team, go and improve this process, and I trust you to do that. More likely, or what we see more often, I should say, is that they will be kind of hovering over them and slowing things down, not speeding things up. But look, the operators, the workers, they are the experts on the process. I don't care if you're an engineer or scientist, you understand the dynamics of how chips are cut by a drill bit in a drill press. These are the guys that do it every day. They know what the problems are. Most of the problems are not going to be in the actual drilling, they're going to be in the processes surrounding that. Okay, the house of lean production. Sometimes when you see the house of lean production, it's very simplified. Sometimes it's more elaborate, like this one. This is actually a diagram that I created when I worked for the Texas A&M University system. And I got permission from my boss to use this in my consulting work and in my teaching here at Navajo Technical University. So, at the very bottom, the foundation is 6S, although a lot of the time, most of the time in fact, it's actually called 5S. But here in America, we have a tendency to neglect safety. So I like having safety in. So it's safety, sort, straighten, standardize, scrub, and sustain. We'll go into all that more later. We need to have level work production. In other words, the guy at one station can't be mostly idle while the guy at the next station is killing himself to get his work done. The two pillars that hold up the structure are just in time. We want the right parts in the right place, the right quantity, at the right time, kitted and ready for production. The other pillar is Jidoka. That is the one where we are working to avoid mistakes. I usually work in a better lighted room where I can just wander all over the place. So the idea of automation, that a machine stops itself if it's making a mistake. Mistake proofing, making things so that we can't make a mistake. And visual management, being able to find things easily because we have labeling, we have places those things should go. And of course that holds up our roof, which is focus on the customer. We want low price, high quality, and a short lead time. Inside, to achieve these, we have flexible, trained employees. I don't know how many of you have worked in a production situation where you spend 8 hours doing essentially a mindless job every day. Oh my God. It's not fun. So we want employees that can do many jobs so that every hour they can shift around and do something different so that life seems a little more interesting. We want them to work with standard work. This is something that we emphasize a lot in industrial engineering in general. But standard work means that we always work with the same tools, the same methods, and in the same order. That feeds into our TAC time, right? Our TAC time is time available divided by customer demand. Our material, first of all, we have a standard amount of work in process, right? We don't want to build up extra inventory because that represents money that could be in our pockets in case we need to make some kind of a switch or buy something. That goes into our one-piece flow. In other words, we only have one piece of inventory by a station at a time. On the other hand, we have right-sized machines. How often in industry or in business have you seen a gigantic machine that is way overpowering for what is needed, right? This machine can make 10,000 parts an hour. Well, how many parts an hour do you need? Well, we actually need 20. Total productive maintenance, the idea that the people who run the machines know them, they can keep them clean, and they can do the routine maintenance. All of this leads into our Six Sigma quality. All right, so in Lean, we have a bunch of Kaizen tools. Kaizen is the Japanese for make good or make better. And when I say Kaizen tools, what I mean is different kinds of Kaizen events. So the first of those is 6S. This is the foundation for all further improvement. We have the generally labeled Kaizen event. That is a focused improvement event on one aspect of what is going on at a workstation or a shop. Total productive maintenance means that our equipment is ready when it's needed, right? We don't send a part over and they say, oh, sorry, machine's down, maybe tomorrow. I hate when that happens. A 3P event is what we use when we really need a big breakthrough in production. So usually that means we totally rethink how we do a process so that we can revamp it for better production. Right? Usually that's because we've done so many Kaizen events, we really don't see how to get much more efficient just using our ordinary events. We have to totally rethink how things are done so that we can break through to a new level of productivity. Standard work, again, same way every time. Value stream mapping, often this is something that we do early in the process, right? We may start on 6S at the same time that we have people doing value stream mapping never mind. And single minute exchange of dies means that we can switch production more quickly for being able to do more of a mixed model type of production. All right, so when we have Kaizen events, very often what we do is we think of them as being one of these four. Our 6S bases, figuring out what are necessary items, putting in visual management, reducing the amount of work in process. Standard work, defining our sequence, our methods, how we do things. One-piece flow, making it so that our products, our parts are flowing through the facility, not start and stop, waiting, working. And in the pull system, we want first-time quality. We don't want to have to send anything back for rework. We want it just in time. We want all of our steps to be linked together. All right, so when we think about 6S, very often the illustration that we use is a fire engine. Think about a fire engine showing up for a fire, right? You can't have the fire chief saying, all right, roll out a 2-inch line, get it set up, and then somebody say, where did I put that last time? No, everything has to be in a standardized place where you can get it quickly, because seconds are going to be the difference between life and death for people. All right, so our 6S's are safety. Very often Americans are cavalier about safety. You know, oh, I've done it hundreds of times and nothing ever went wrong. Okay, well, maybe the 101st will be the lucky time. So we have to fix these unsafe conditions, whether it's broken tools or broken electrical sockets or whatever the situation is, trip hazards. All right, next, safety actually continues through a 6S event. What we do first is we pull everything out from where it's hiding and we sort it out. Because there's going to be things that are needed and things that aren't needed. And we need to take those things that aren't needed and put them in a red tag area. All right, so once we've figured out exactly what's needed, we organize it. Where are we going to put it? Sweep is an important element. Often when people say sweep, they mean being able to sweep with your eyes and see that everything is okay. But we also want everything clean, and we want to make it visual so that there's no question about where to get things or where things go. Standardize, we want to establish who does what, when they do it. So very often, we'll create a schedule. All right, at the end of the day today, Al sweeps up. Tomorrow it's going to be Bill sweeping up. The day after that it's going to be Clem. Oh, I did it ABC. I didn't even think of that. And sustain. Once we've got that, we want to keep it in order, and we want to improve our order. Okay, well, I have no one to ask questions of. All right, so visual management is the idea that we have as much information at the fingertips of the people working. So this is actually from a company I consulted at. So this was the sign next to the door when you were about to go into the shop, right? So it says you need your PPE, you need your ear protection, it's a welding area, so be careful of your eyes, overhead cranes are in use, and look out for the forklift. All right, so I've already showed you safety instructions. This is just that same picture. You can have operating instructions. This is actually a coffee maker I used to have a long time ago. And it was screwed in up under the cabinet. The problem was, if you didn't do everything exactly right, you'd turn on the coffee maker, you'd come back, and you'd have coffee all over the place. So on the basket here it says, push in firmly, right? It tells you where the beans and the coffee grinder are, where to put the water in, that the on-off switch is right there behind the door. At that same house, I don't know who had wired it up, but it was the most illogical possible arrangement. So I went around the whole house and I labeled what things were. Okay, this is the porch light, it uses 23 watts. This is the kitchen overhead, it uses 26 watts. I just did that to the whole house. Right? And a trigger for action, in this case, I'm showing you, one thing I found out when I started doing Lean people start applying it at home almost immediately. As soon as they learn Lean, they're like, oh man, I can see some things I want to change around here. So I had already gotten to the stage where I had a laundry basket for black, laundry basket for white, and laundry basket for color. This is actually super full because I had just done a 6S on another area of the house, and a lot of that stuff got pulled out, and I said, oh man, this is kind of dusty, and threw it in there. Okay, why I have this slide twice, 3 times, oh my God, stop the show. All right, one thing that we often do with visual management is we create production control boards. And some people call these something else, which I can't recall at the moment, but that's not important now. All right. What it is meant to do is give us a one-glance status of the job, right? So the manager of a shop can step outside, he looks at all the production control boards, and he can see what's on track and where somebody might need help. Let me start with widget assembly. Okay, in this case, we assume that the goal is 48 in a day. They've marked off that they've made 30 already. And then we have an area for problems, right? And so it says, under problems, it says, some widget bodies have improperly drilled holes. Okay, we accumulate these problems because they may be the basis for other lean events down the road. Here we have a much more complicated type of board. Here we have a job that takes all day. I know what I told you about Blivets, but I couldn't resist putting it in here. We have 3 different people who have to work on this. Mechanic A, Mechanic B, and the electrician. Okay, so hour number 1, you need Mechanic A to do 2 tasks and the electrician to do 3 tasks. The blue cards mean that task has already been completed. Right? So we come down here to hour 4. Well, Mechanic A has 4 tasks that he hasn't done, but the electrician has already finished his task for hour 4. Right? And then in the afternoon, you have Mechanic B coming in to help. All right, so that's kind of a simple way a really long job can be done. And that was one of the ways that we handled aircraft assembly in our aerospace endeavors. All right, so with standard work, we have to do it the same way every time. All steps done in the same order, all work to the same standards, and all work with the same methods. At one of the shops, when I was working in aerospace, I went into the transmission shop, and we were working on CH-47 transmissions there. And they had a bunch of different teams that were all putting together transmissions. So the problem was no standard work. You had no idea when people would be done putting a transmission together. So the first thing I did was I went and I consulted the technical manual and I put down all the steps in order, and I put that in the computer, made a nice, neat little thing. Then I took it around to every team. Well, some of the teams looked at it, yeah, that's how we do it, man. Why, what's the deal? But other teams are like, what? You can't put a transmission together like that? That's crazy, it won't work. Standard work, very important. Our standard work instructions can just be labels on the devices, or it could be, well, I'll show you in a minute some other ideas. So this is a more close view of that coffee maker I was telling you about. This is from a dryer I owned, seems like 1,000,000 years ago, where they had instructions on the inside of the lid. Sometimes what we're doing is a more complicated job. So sometimes we can use a check sheet or a checklist, but in this case, we were actually putting together instructions for how to put a part into a CNC machine to be finished machined. Right? So we actually were doing that with a binder where there would be one step on every page. So step 5 here is put the machine, the fixture in the machine, and make sure that the x-axis is indicated so that it's so the fixture is parallel to the machine table. Okay, see, and here's our little device that checks whether or not it's parallel. Then step 6 is we have to use the indicator to trace the center hole so that the machine knows exactly where the part is. Part of standard work is doing kitting. In other words, making a kit that has exactly what's needed and no more to put together a product. So we need everything that's needed for the task except possibly the tools and supplies, although I noticed that Boeing at their 737 assembly, they actually push out kits for different processes where the tools and supplies are in there with the parts. Our kits have to be arranged in an order. We assume we work from right to left because most people are right-handed. Now that means that us lefties feel like we're doing things backwards sometimes, but we're the minority. So we want the first item or items on top. If we have multiple layers, then we want the second layer to contain items that would be used maybe in the second step and on down the line. And this is just something I made up to illustrate a kit. Now very often what we do is we create spaghetti charts to show the amount of movement before we did lean and then after we did lean. So we start with a layout, drawing of the layout. We draw the path of travel so that we are making the travel visual, and we're just going to show a notional operation. And on this slide I can never remember if I have to hit the forward button again. Oh yes, I do apparently. Alright, so here's our guy. He starts at the workbench. He goes to get parts. He takes those over to the arbor press. Then he's going over here to the supplies and getting the supplies he needs. He goes back to the workbench to do something no doubt valuable. Goes to the toolbox. Then he goes back to the workbench and comes down to the lathe to do part of the operation. Goes back to the workbench and goes over to the drill press and then here to the cleaning machine. And then it's finally done. He takes it for inspection. And so this is a spaghetti chart. After we do lean, this should be the path of travel should be simpler. The next idea that we need to bring up, part of visual management, is the idea of point of use. Everything should be in the place it's used. If we need equipment in two places, we should either have one for each or put the workers with that equipment in between them. I know I worked in an organization where at one shop they had a pegboard of all the tools. Okay, well that's a great idea. Makes it very easy to see if it's there or not. The problem was They had one copy of every tool. They had about 12 people working in this shop on things that were similar to each other. So if you went over to the pegboard and the tool you needed was missing, you were stuck. So one of the suggestions I gave to them was, how about we just like have a set of tools for everybody? They looked at me like I was insane. But these were all simple. Most of them were made out of a couple of pieces of pipe welded together. What the hell? Once again, we see my old coffee machine, but we also see that we have the sugar, we have the coffee filters, the coffee beans, the coffee grinder, etc. The only thing that's not there, of course, is the milk, because that would spoil if we left it out. When we're doing lean, we need to think in terms of ergonomics. In ergonomics, we think in terms of the strike zone. From your shoulders to your knees is the part of our body where we are the strongest. So we want to minimize the amount of having to reach way out to get something, or minimize the twisting that we have to do our job. The more something weighs, the closer we want it to knuckle height. In other words, where your knuckles naturally fall when your arms are down by your sides. All right, so value stream mapping. With value stream mapping, it defines the plan that we are going to use to get to our future vision. So we need to define the requirements and the processes that are used. We need to map the information and material flow. Identify what is the current state of these processes. Identify our opportunities to improve in the areas of cost, quality, and delivery. All right, so when we're preparing for value stream mapping, first of all, we want to define the boundaries. Is it going to start with the raw materials and go all the way to a finished product being put in the hands of a customer? Is it going to be for just one shop? Is it going to be for just one assembly line? Exactly what are we going to do? That has to be the very first step of value stream mapping. We want to define the value. What does the customer want versus our internal requirements? As an engineer, I know if you just turn the engineers loose, they will keep adding features until the apocalypse comes along. Hence the old expression, eventually you have to shoot the engineers and put it into production. All right, and then we're going to set up our map. We're going to draw as much as we know right now about the process. And that's going to be the basis of our value stream map. All right, so our process in creating a value stream map, first we have to capture all the current conditions. So let's observe and gather data. Now, a lot of people think, oh, well, I can observe here from my computer. No, you can't. You have no idea what's going on. Get on the shop floor and get real information. The Japanese call the shop floor the gemba, the real thing. We want to map the flow of our items. How does the material, how do the products flow in the system? So we're mapping that flow of information as well, because information is often something that is in short supply on the shop floor. Any shop you go to and you see the workers constantly having to go to the manager and ask questions, information's not flowing. So we want to see how that flows in the system. We want to find the gaps in the knowledge and the information that are causing problems. We're going to add data boxes and highlights to our value stream map so that we are putting down real information and real data. All right, so to break through, in America we say go back to the garage. The Japanese say go back to nature. How would we do the process if we had never done it before? We want to brainstorm with our team of experts, and that's those who do the process every day. It's not the vice presidents, it's not the engineers, it's not the marketing guys. We want those guys to be in the event, but understand the real experts are the guys and girls that do it every day. Uh-oh, I said girls. Now I'm going to be in trouble with the PC police. Don't throw out any ideas on the first pass. Look, when we brainstorm, people are going to bring up some really wild-ass ideas. But a lot of times, that wild-ass idea is actually practical and the best idea that's come out. Again, think of nature. At Boeing, the guys that we would ordinarily call expediters that are bringing parts to different stations are called water striders, a type of bug that just walks across the top of the water. All right, so in our vision for our value stream mapping, what are the natural groups of products or services? Now, those of you with an industrial engineering background, you're going to know some techniques for how do we group parts, or how do we group different kinds of services, whether it's rank order clustering or some other more complicated scheme. We want to develop our ideal state map. So we've got a current conditions map. What would we like this process to look like way in the future when we're done? What are our opportunities for improvement? What steps get us from where we are to where we want to be? All right, so we've got a current state map, we've got an ideal state map. In between those, we have the future state map. That should be what we expect the process to look like in 6 to 12 months. So we put together action plans and we track those actions to make sure that they're being completed. So action plans should be on improvement opportunities. Do we need a Kaizen event? Do we just need to say, hey, I need you to swing by this station every hour and make sure they're okay? What do we need? And we identify what changes we want to make to get to that future state. So when we're tracking, who is the person or persons responsible for implementation? So often I've had to argue because people want to put down, oh, well, just put down the production manager. No, Who is the production manager? Put his name down there. And we want to communicate our improvement. If people don't know what improvements are happening, they may think nothing is happening at all. All right, so if we do a 3P event, the 3Ps, actually there's argument in the Lean community about what those 3Ps should be. I put down product, process, and people. We need diagrams of what the flow is and simulations possibly of what could be our future flow. What are our key words in our processes or our production? Always think in terms of going back to nature. What does nature do to solve problems? How does nature design things? Oh, the screen's making me seasick. We want to come up with 7 alternative layouts that would all be an improvement. So we develop those 7 ideas, and then we say, all right, how feasible are these? Are we going to be able to do this? We want to evaluate what are the pros and cons of those 7 ideas. What are the underlying themes that are in most or all of the ideas? And what we're going to end up doing is we're going to put the best parts of all the ideas together for our final design. Cold tea, nothing like it. All right, so total productive maintenance. This is just a quick overview of Lean. We're not going to go too deep into these ideas. The people that are operating the machines know when something is going wrong. They should be the ones who are keeping the machines clean and operational and do the routine maintenance. Just changing small parts that have to be changed, possibly even changing the oil in the machine, etc. When we do that, we're increasing our machine availability, our performance efficiency, whether it's OEE or some other measure of our performance. Oh, well, I put down OEE. What we're going to eliminate is unscheduled machine downtime, right? That's always a killer in production. The hidden losses that come with that unexpected downtime. And often we can get rid of some process defects by this method. All right, so Six Sigma is a mathematical statistical process where we work on quality problems specifically, whether that's in a product or a service. Motorola, when they originally designed this, they didn't like that 6 standard deviations still left 773 defects per million as possible. So they redefined it as 3.4 defects per million opportunities. Often we use Six Sigma with Lean as Lean Six Sigma. Now, one thing I would say though is if we go into a brownfield, we can do some Six Sigma analysis, but we can't always trust the numbers. I remember one place where I went in when I was working with Texas A&M, and we had access to their database of how long it was taking to do processes in every shop. right? So we're doing all these analyses and we're saying, oh man, look at this. We got to go to this shop, this shop, this shop. Well, one of the old hands from the company comes around and they're looking at what we've done and they're saying, guys, none of this information has any value whatsoever. Because everybody, when they're inputting the numbers, is lying to make their shop look better. So very often we have to start with a straight lean approach, and as we get people on board and we're building trust and they know they can put in accurate figures, then we start to drill down with our Six Sigma methods. But Six Sigma still has one possible problem. It can't capture anything that is a problem that doesn't have numbers associated with it, right? So for that, we need Lean to fill in those gaps. All right, so in Six Sigma, we have the DMAIC process. We define the problem. We find out what the measurements are to be able to drill down on the problem. We analyze how to fix the problem. We implement those solutions, and then we control to make sure that what we've implemented is right, that is being followed. If it's not right, we need to go through the process again. Okay, I said before, when we do Lean, we need real information and we need fresh information, right? If they just put a bunch of old dusty historic records on your desk and say, there you go, that's information you can get your teeth into. No. We need the current data. So, we need to do the kind of old-fashioned work measurement that is so often spit on these days. Because we can see the waste. We can see the process flaws. We can see the issues with layout. We can see our safety and ergonomics problems. And we will have recorded data to back that up. All right, you'll notice here, I've got a guy with a camera taking pictures of people working. Video is very powerful in work measurement because we can look at that video over and over and over again, identifying problems, and we can take clips out of that to show management. And I always love the little gasp of astonishment that you get from management when you show them some of these problems. All right, so we want to observe particularly problematic areas, right? The things that are going good, don't even bother with work measurement right now. We're looking for variation. Variation is the enemy of the industrial engineer and lean people. What are the equipment problems that they're having? Have we got a really bad process? These films can theoretically in the future also be used for training. Okay, so we skip that and we go to, look, a lot of lean is common sense. When we're making these improvements, we want to ask, is our cost going to be lower? Right? If we add more steps, we add more complication, that ain't going to happen. Does this improve the quality of our product? Does this improve the delivery of our product? Is it going to be safer to work there when we're done? Is it going to make this a happier place? Happier employees are more productive employees. The idea of ruling by fear is not at all helpful. Okay, well, and here's my thanks to various people who helped me put this together in various ways. And I want to thank you very much for watching this presentation. I wish I had some people here with me so I could have run the production exercises and let you see Lean in action. But in the meantime, stay safe, stay healthy, and when the fields are white with daisies, we'll meet again.